are used in sense statements need to have concrete values, and they do not allow matching operations. And the receive templates, so the expectation of a template in context or in relationship to a receive statement, they may contain some wildcards, some special symbols, which I will explain on the next slide. And these are matching operations or some symbols which express some freedom of the expectation. Templates are all in the global scope, and they apply for message-based communication, but also for procedure-based communication. Very powerful instruments of TTCN-3. Here we have some examples for templates which we would like to use in a send statement. So this is a very simple integer value which we can use in a send statement. It has a concrete value, or here we have a concrete value of an octet string. These templates, M_I or M_O, can be used in send statements which allow messages of type integer or which allow messages of type octet string in this example. If we have a template for a structure type, here we have to give for each field an information to be sent out for that field. If we use the keyword omit, then this field must be an optional field. We cannot use the omit keyword for a field which is not optional. Omit means this field is not present, and this could be used only if the field has an optional declaration. The value can be omit or a concrete value based on the field type, or it can be the outcome of a functional calculation. For example, here the function f with the argument for will return a value, and this can be used in a template for a send statement, or here for the field of a template in a send statement. Templates which refer to a union type can also be constructed or written down, but again, if you apply union type, you have to say which variant or which type of the collection. Union is a collection of types, and you have to say which selection you will make in case of the union type. So union can be a collection of any type, but if you apply a template on a union type, you have to decide which type will be applied based on the name of this discriminator, which is given in the definition of the union type. In the receive situation, we have more freedom. Not only concrete value or the omit keyword, you can also use some question mark to say, this is my expectation of a specific message of type integer. The question mark means any value, so you have not to say a concrete value, you can accept any value. Of course, a question mark cannot be, a template with a question mark cannot be used in a send statement. You cannot send out a question mark, but you can express your expectation that you are happy with any integer value, and you give the expectation by writing down the question mark. The question mark can be used for the whole template, but can also be used for a single digit in an octet string, for example. The expectation for the integer can be a concrete value or the question mark or whatever, but it can also be a list. You can expect a list of it for the incoming value. It means the real incoming value will be compared with your expectation. If a value comes in with the value 5, it will match to this template, because the 5 is in the range of these templates, these integer templates. The value 3 will not match with this template MWI, because the 3 is not included in the scope of these templates. So the scope of these templates, the expectation means the value, the integer value 1 or 2, or any integer value between 4 and 10. So this is one example of an expectation for an integer value, which allows ranges and concrete listed values, and it's up to you what to expect in your specific situation. For the structured type templates, can specify for each field of the template an expectation. We have again the possibility to give a question mark to one of the fields which means any value, but we can also use the star, which means any value or no value. If there is an optional field in a record structure, this can be omit, and if you are happy also if this field is not present, you can make use of the star symbol, which is a wildcard, which is an expression of your expectation, but it can only be used in optional fields. So it will be a compiler error if you use it for a field which is not optional. We have some more features here. If you have an optional field and you are happy if the field is not present, but if the field is present, you stick on a concrete value, you can apply the if present keyword. So there are really a lot of features together with templates to express your expectation. So not only the wildcards, but also the if present keyword. You can make again the templates also for union types, but then you have again to tell which kind of type you are expecting, because union is a collection of different types, and always you have to say which type you are expecting in the context of the union type. And here are some more templates. Parameterized templates are very important. So templates, I mentioned, nearly is often half of the code, line of code. So a lot of templates, and you need to powerful means to avoid repetitions. So you will benefit of the parameterization of a template. So to avoid too many definitions of templates, just to instantiate template with a parameter, and this is a parameterized template with a formal parameter p_i, and this parameter need to be filled in a send statement or in a receive statement if you make a reference to m_r2, and the value, the argument, will be used in the field where the formal parameter appears. So parameters helps to reduce the number of templates. Here's another example for a parameterized template with two fields. Here the argument is as the identifier p_r1, and is of type subrecord, and it will be used in the first field. The modification of templates had been introduced in the DNS example very shortly. That means if we have the template, for example, m_mytemp1 with 3 fields, we may reuse these templates with a small modification. And an example is here given in the next template definition. This is a new template, my template 2, which makes a reference to my template 1. In fact, it modifies the context or the content of my template 1, but only the fields which are listed in this definition. So my temp 2 is originally defined by my temp 1, but the field 1 will not 123. It will be overwritten by the value omit, and the field 2 will not be the character string a string, but it will be the character string a modified string. The field 3 is not listed here. That means it is the original field from m_mytemp1. So we only specify the delta, the difference against the basic template. In this case, the basic template is my template 1. So field 1 is from the original, this is overwritten, and field 2 is also overwritten. You can combine the parameterization of templates with the modification. Here we have a parameterized template with one formal parameter, p_i, and here we have a new template, mytemp2, which is a modification of this parameterized template, m_mytemp1. It is important to repeat all the formal parameters from the original template also in the new definition. You can put some more arguments, some more formal arguments to the definition of the new template, but if you make a reference, modification reference to an existing template, that means all existing parameters from the original one should be repeated but can be extended. In this case, my temp2 has the original field from my temp1 with regard to field 1 and field 3, and the field 2 will be overwritten. As we see here, we have the definition for field 2 in the my temp2 declaration. So you can combine parameterization and modification in the context of templates. This gives you a powerful means to express it very economically and to reduce the number of templates. So for the receive situation, you can have these expectations which are beyond specific values. Of course, you can specify specific expectations, or you can specify that the parameter should be omit. But instead of values, you can give a list of values, or you can specify that you expect the complement of a list of values, and you can use the question mark for as a wildcard for any value. You can use the star as a wildcard for any or no value. In the context of record of and set of, you can use the wildcard for a single element in a record, and also star in this construct for any number of consecutive elements of a string or of a record of. So a star could be more than one field. If you have a record of integer, the star represents more than one field. You can specify your expectation by using the length restriction, that you expect any string of a particular length or any record of or set of value with a particular length of field elements. And the if present, I already mentioned this, is the construct which allows the absence of value, but if the value is not absent, it sticks on a particular value which is given in front of the if present. So there are a lot of details here. You will forget them tomorrow if you are at home. So, but you have a little summary in this book, and you can see what is in, and you can also refer to the quick reference card or to the standard. By the way, the standard is free and open for download, and it includes a lot of examples. Sometimes it's hard to find the example because it's in section 534, but if you go via the quick reference card, you find the examples quite soon and quite fast. And I think there is a book existing on TTCN-3 as well, even in the second edition, and it is quite good. It is written from Nokia colleagues, but it's still 5 years old. The first version had been, I think, 10 years ago. The second version had been 5 years ago. It's also very good, but I think the standard is free and the book costs money, I think €80 or dollars, and it's good. I would be executed, then the executable calls the codec, and the codec tries now to decode this information into a TTCN-3 abstract value based on these expectations, based on this template reference. And if this happens and it matches, the executable will be informed, and the scenario given in TTCN-3 can be continued. So you see, in both directions, sending something to the system adapter test or receiving something, we have software which is involved, namely the system adapter and the codec. And if the test case terminates, there's no activity anymore at the system adapter and the codec. And this is somehow to remember why we have these decoding hypotheses. If you get an octet string with these digits, it is up to your interpretation. If this is really an octet string, if this is an integer, or if this is a character. But you need some idea what you expect. And the expectation is due to your reference to a TTCN template. And the template reference is something which informs about the structure which you await. If you await a character string, or if you await an integer value, or if you really await only an octet string. And due to this template, this expectation, the decoding takes place and the decoding happens, and you get the TTCN-3 value coming from an incoming octet string. So the codec needs some activity or some access to type information. The executable provides some functions which allows to retrieve type information or to construct type information, because if an incoming value need to be translated into a TTCN-3 value, we need to build an object which represents a TTCN-3 value. And this is the subject of the codec, to apply some operations at the TCI interface which helps to construct TTCN-3 values based on the TTCN-3 type information. So there are objects in the executable which represent TTCN-3 values, and these values, these objects, depend on the related type. But these are details which the developer of a codec needs to know, but at least it's good to know that there is something ongoing, that there is an activity, and you can follow in a log statement or a log trace if the codec has been involved, or where is the status of your execution. So there is not a secret, and you will always be able to see in which status the execution of the test system will be. So the codec interface makes use of these operations which are required by the codec, which are provided by the executable. And the codec may also make benefit of a third-party codec. So sometimes text strings are very hard to analyze, and sometimes there is already software available which can decode text strings. So the codec can also make use of third-party codecs, because this is a piece of software which can invoke some library and can benefit from the existing libraries. So the codec has two functions, the encoding and decoding. The encoding makes a translation from TTCN-3 data to real-world data. The decoder makes a transformation from real-world data based on a hypothesis to TTCN-3 data. This is here also illustrated. So we have the test component. The codec is always between, if you have a communication to some system on a test which is outside of the test system. So the encoding is based on the template information, of course, because this is the test data we would like to send out, and the result of the coding will be an octet string, a bit string, which goes out. And the other activity is to understand these octets, and based on an expectation given by a template reference, we construct, or the codec constructs some TTCN-3 value which is related to the TTCN-3 data type. Yes, so this was not an excursion, but of course somehow maybe surprising you that this is part of the TTCN-3 technology, but you learned that it is part 5 and 6, which are part of the multi-part standard, and these runtime interface and control interface are really standards which need to be fulfilled by the tools, and all these events and logging information which is standardized must be available by the tools, and therefore there is a standard quite good to make sure that the execution and the execution of tests are really in the right way, independent of the tool. So you have a notation, but also some constraints regarding the execution and the implementation of a test system. And this is more than a notation. It's an implementation view on test cases, on test suites. And therefore it belongs to the technology. Yes, so we remember these architecture with the green in the middle, the red and the blue. So some of these components are provided by the tools. The test management interface is provided by the tools. The component handler is provided by the tools. Some of these boxes are provided by solution, that means plugins for web service, for example. The codec and the system adapter and the platform adapter somehow is provided by plugins. This means TTCN-3 solution, but of course you may also implement it manually. If you have no solution, if you have a very particular dedicated system under test with your own interfaces and you create the operations, then of course you have to create an own system adapter which serves really the interface which you would like to test. So at some point you need the real interface to invoke the real functions which are provided by the system under test. So sometimes you need a manual implementation, but at the end, and this is what I love very much in TTCN-3, you have a high flexibility, you have a separation of concerns. You have the logic in the executable defined by TTCN-3, you have the access, you have the decoding, everything is separated, and you can exchange something, or if there's an error or some modification, an update necessary in the codec or in the adapter, you don't have to touch the TTCN-3 logic. You just modify or update the system adapter if you have another operation regarding the system under test, or if the coding will be changed due to a standard modification. But you don't have to touch the TTCN-3 logic if some access or some coding changes. So you have a separation of concerns. And this is, I think, quite a good approach, in my understanding, that you can keep the logic, and test developers with non-programming facilities can write down test suites, and this is a good separation of the different tasks in test.